Hello everyone. In this video, I will be discussing the basic concepts of projectile motion and identifying what forces does an object go through when projected from a certain height. Basically, the objective of this video is to define projectile motion and to distinguish between the different types of projectile motions. To study projectile motion, we firstly must decompose the motion into its two components, the vertical component and the horizontal component. The vertical component, it defines how long it will take for the projectile to hit the ground, while the horizontal component of the motion determines the range of the projectile. Furthermore, an example of horizontal motion would be a ball rolling freely along a level surface. Note that the horizontal velocity is always constant. Secondly, the vertical motion can be described as a freely falling object. Here, the force is due to gravity, and the vertical component of the velocity changes with time. Finally, parabolic. Parabolic motion can be described as the path traced by an object accelerating only in the vertical direction while moving at a constant horizontal speed. This can be a parabolic motion. Moving on, the path which the cannonball takes is an example of a projectile motion. We can see that the horizontal velocity is constant all the way as the vertical velocity changes with time. This photograph shows two balls that starts to fall at the same time. The one on the right has an initial velocity in the x direction. It can be seen that the vertical positions of the two balls are identical at identical times, while the horizontal positions of the yellow ball increases linearly. This example shows the path of the projectile fired with an initial velocity of at v0 at theta to the horizontal. The path of the motion is in black dashed line and the velocity vectors are green arrows. Now, the acceleration, which is equal to the total velocity divided by the total time, is 10 meters per second squared. Since the motion is against the gravity, we have to take the acceleration as negative of the gravity. The critical component of most problems is the definition of the boundary conditions. For example, the horizontal and vertical components of the motion. The problems may differ in what you are being asked to do. For example, determining the range of the projectile, its flight of time, etc. Finally, the confusing part, the formulas. As you can see, the variable Vf is for the final velocity. Similarly, Vi is the initial velocity, R is the range, S is the distance, and T represents the time of the projectile motion. We have certain proven formulas that we can use to calculate the missing values provided some of the variables are given. Now, the part that most of the students get confused is the range and the distance. The range refers to the distance of the projectile head covers, whereas the S in the formula represents the height which it has been fired from. Now this little clip art will be showing what is exactly S and R. For example, if this is a projectile motion and a ball is fired, now this will be the S and this line would be your R, which is the range.